Welcome children. Now we are going to discuss again from the unit light the revision of it. In our previous class we discussed about how the image formed by a spherical mirror by different positions of mirror. That means the object is at a different position from the mirror, and how we got the image and the nature of that image also. Now we want to discuss more about that. That means how we get that image can be represented by using array diagram. That means a source of light from one point of it, so many light rays emerge. To represent a ray diagram, any two of the rays we use, and the intersecting point of that we consider the image formation at that point. So here you see a concave mirror. Now this point and another this. These 3 points you already know. The point P is the midpoint of the mirror, and what it is called? It is called the pole of the mirror, that you know. Then this is the point we used to say as a principal focus, and this is the center of curvature. First, a ray of light incident parallel to this principal axis. What happened to this ray after reflection? See, the reflected light rays passing through the focus. Here you want to remember the incident ray is parallel to the principal axis. Reflected ray passes through the principal focus. Through the principal focus in the case of a concave mirror. Now you consider about a convex mirror. This is the principal axis. This point is called, what it is called? It is P. The name of this point is called pole, and this ray is parallel to this principal axis. Here you see its focus is here, and the center of curvature is at this point. This light ray, which is parallel to the principal axis, what is actually happens? These rays when it reflected. When this ray reflected like this, it goes. But when we extend, this ray appears to coming from the focus of the mirror. Now, these two cases, in these two cases, light rays parallel to principal axis here also. In the case of concave mirror, the reflected ray passes through the principal focus. Here, how it passes appears to coming from the principal focus of the mirror. Now, you want to remember about these two. Now, another light ray. First of all, you notice what kind of mirror is this one and this also. And what is the name of this array? That is this line here also. Now, this mirror is it concave? Yes. Then what about this one? Convex. Here, just before we discussed a ray parallel to the principal axis after reflection passes through its principal focus. Now consider another ray which is passing through the principal axis. Here also, here the ray is passing through principal focus. And after reflection, what happens to this reflector ray? Just before we discussed a ray which is parallel to the principal axis. After reflection, it passes through the principal focus. Here the ray incident to the mirror through principal focus. Then what happened to its reflector ray? The reflector ray becomes parallel to the principal axis. Here the reflector ray becomes parallel to the principal axis. Here you see a ray of light which is coming towards the principal focus. This also here reflector and it becomes parallel to the principal axis. Now these two things you want to remember when we draw ray diagram. We want to use any two of the rays, and one is this one, that is a ray passing through principal focus. It reflects and becomes parallel to the principal axis. There a ray coming towards the principal focus. After reflection, it also becomes parallel to the principal axis. Now see, another case. This is a mirror. Its surface is not plane, so it is curved. Hence, it is called spherical mirror. And this is the principal axis, and this is at the point B at an angle of 90 degrees. So this one is normal here. This is the principal focus and this the draw curvature. Now see what happens to a ray which passes through the central curvature that incident on the mirror. This ray is incident in this mirror normally or perpendicular. So it is reflected back along the same path. Now you want to remember, if the ray is incident on the mirror through its central curvature, after reflection it retraces or travels along the same path in the case of a concave mirror. Now you observe in the case of convex mirror. This is the principal axis and this focus, and this one is center of curvature. A ray is traveling towards its center of curvature. A ray traveling towards the center of curvature of the convex mirror that strikes on the mirror. It strikes here normally, so it returns along the same path. It returns along the same path or retraces along the same path. In the case of which mirror? Convex mirror. Then another one more ray that traveling towards the pole. What is going to happen after reflection? This concave mirror, this is the pole, and when a ray of light is incident here at an angle, suppose this angle is I. This is the incident ray and this one is the normal. This angle between incident ray and normal is the angle of incidence. In the case of reflection, we know angle of incidence equal to angle of reflection for plane mirror as well as spherical mirror. So here it reflects in this way with the same angle, that is I itself. This angle is angle of reflection, but it is equal to I. This is the ray when strike at the pole, and here it shows how that one is reflected. Now, in the case of convex mirror, principal axis pole, a ray incident at an angle and this reflected along this side with the same angle. Now with these rays we want to draw image formation. When we draw the image formation by spherical mirrors, we use any two of the rays, and when we consider any two of the rays where their reflector rays meet, there we get the image. First of all, we can discuss about image formed by concave mirrors. Image formation we can represent by using array diagrams. First, we can discuss about how the image is formed by concave mirror when the object is at infinity. First case, object at infinity. Object where is at infinity. This is the concave mirror. Its principal axis pole. We know when the object is at infinity, the light rays travels parallel to the principal axis. So the rays traveling to the principal axis. This is the focus. We know a ray parallel to the principal axis after reflection, it will meet to the focus. or passing through the point focus. That means here we get the image. So first of all we want to know the position of the image, where the image is found when the object at infinity. Position of image, where it is at the focus. We got the image at the focus of the concave mirror when the object is at infinity. Other properties of the image. That image is highly diminished. That means very, very small. Highly diminished or very, very small. That image is real and also inverted. Image is real and inverted. When the object, where the position of the object at infinity. This is the first case when the object is at infinity. Now we are going to place concave mirror, pole, focus, center of curvature, and this just behind. Now the object is just behind the center of curvature. Now we want to draw the image formation by using ray diagram. First we can draw this ray which is parallel to the principal axis. We know it passes through the principal focus after reflection. Now this is the reflector ray of this one. Now we can draw another ray which is through center of curvature. And this center of curvature, it strikes on this mirror. This ray is going through center of curvature. We know these two meeting at this point, because we know a ray passing through center of curvature, it reflected back along the same path. So the two reflector rays meeting at this point. Here we get the image. So where the image we got in between C and F. So the position of the image is in between C and F. See, the image is this much size and this object is this. Image here we got a small one. See, it is also real inverted. That we can observe from this ray diagram. Now, where we place the object is placed just behind C. Now again, in another case, we are going to place object at C. This pole, focus C. Object is at the center of curvature. First we can consider a ray parallel to principal axis. We know after reflection it passes through the focus. Now we can consider another ray which is going to the mirror through focus. This way. We know a this manner it will reflect parallel to the principal axis, so it will reflect in this way. These two reflector ray meeting at this point, here we get the image. So objective here, image here. Both the position of object and image are at the focus, are at the center of curvature. So position of the image when we consider, when the object at the center of curvature, when the object at the center of curvature, image also at the center of curvature. So image its position at the C. Then actually these two rays are meeting, so the image is real and also it is inverted, and size of image is same as that of the object. That means how much is the size of the object, that much size the image we got. Suppose the object is at a height, suppose 2 centimeter, then the height of image we get also 2 centimeter. Now at first we place the object at infinity, then just behind the C. Now at the C, then the image also at the C. Now we can place object at some other point. Where we want to place the object now, that all we discussed in our class. So you know, now we are going to place this pole, focus, center of curvature. Now we are going to place object in between C and F. Now the position of object is in between C and F. First of all, we can take a ray parallel to principal axis. After reflection, it passes through focus this way. Now we can draw a ray to C this way, to the mirror. This ray is through central curvature, so it is reflected along the same path. So these two reflector rays meeting here. Where we got the image behind the central curvature. Behind the central curvature, we got the image. So position of the image when we consider, where the position of image behind the central curvature, behind C. Then see the size of the image is large. These two rays meeting, so it is real and inverted. So when we place an object in between C and F, we get the image behind central curvature of the concave mirror. It is real, enlarged, real and enlarged or large in size. Now we can place object at F. Here is the position of object. First of all, we can take a ray parallel to principal axis. After reflection, it passes through focus, which we drawn before. Now another ray which is passing through the center of curvature. Now A ray incident on the mirror through center of curvature, reflected back along the same path. See, these two rays now parallel. We know the parallel rays will meet at infinity. So, where we get the image when the object is at F, when the object is at the principal focus of the concave mirror, we get the image at infinity. Where we get at infinity. And what are the other properties? Very large image. We got very large image. They are also real and inverted. That means image we get at infinity. This very large image that also real and inverted image we get. Now on more position we can place the object. Can you say where is that position? Now we are going to place object. This is ball, focus, center of curvature. Now object is placed in between F and P. Where we place the object in between F and P. Now we know to get an image, two rays required. Two rays when these two rays when strike on the mirror, they reflect. Where that rays meet, where the reflector rays meet, there we get the image. First ray, it is parallel to principal axis. It passes through principal focus after reflection. Another ray which is through center of curvature. This way. Here these two are not meeting, but we are going to extend these rays in this direction. Now we can see these two are meeting at this point. And here we got that image. See, where we got the image means we got the image on the other side of the mirror. Where we got on the other side of the mirror. Actually, these two reflector rays meeting? No. They appears to be meeting. So, the image formed here is not real. Image here formed is not real. Otherwise it is called virtual image. What kind of image? It is virtual image. Now, is it inverted or erect? It is erect image. This an erected image. What about its size? See, this is the size of object. What about the size of image? That image size is very large. So, the image is not real, large, erect, and where we got the image means we got the image on the other side of the mirror. Where we place the object, we place the object in between the focus and pole of the concave mirror. These are the image formation by a concave mirror. Now, we want to remember about image formation by convex mirror. Before that, you know, what are the uses of concave mirror. What are the uses of concave mirror? Concave mirror can be used as the reflectors of headlight, searchlight, and also in torchlight. So where it is used in torchlight, headlight of vehicles, and also in searchlight. Where in searchlight. Then another user, it can be used as a, that means large concave mirror we can use as a makeup mirrors. What kind of mirror? Makeup mirror. It can be used as a makeup mirror. You know, some two more uses of concave mirror. Which are they? Try to remember. Another two more uses of concave mirror we already discussed. Which are they? It is used by dentist or dental doctor to view the teeth in large size. Then another one is a large concave mirror used to reflect sunlight to produce heat. That means in solar furnace, where in solar furnace to produce heat, large concave mirror used to reflect sunlight to a certain point, so that the heat from the sunlight used to make water to boil and to produce steam. So when you remember about the uses of concave mirror, what are the things you want to remember? It is used in searchlight, headlight, and also torchlight. Then it is also used by the dental doctor. Then another is in solar concentrators. They are also being used to produce heat. Now we can discuss about image formation of a convex mirror by using ray diagram. In this case, at first we are going to keep the object at infinity. See, this is a convex mirror. Its focus, center of curvature, pole. When light from infinity, it becomes parallel to the principal. It becomes parallel to the principal axis. When these rays incident on this mirror, it appears meeting or passing through focus. So this is the position of image when the object at infinity. When we place an object at infinity, where does the image we get? Where does the image we get in the case of a convex mirror? Where we get the image at its focus. So position is at the focus of the mirror. This image is highly diminished. That means it is very small. And actually these two not real, otherwise it is called virtual image is getting. Virtual image, this image is virtual, so it does not get on a screen. It does not get on a screen. Virtual image, and also we get here the erect image. Here we get what kind of image? We get erect image. Now, position of object other than infinity. See, here is the position of the object. Now, array parallel principal axis. It appears coming from focus. Another ray towards center of curvature. It reflected back along the same path. These two rays meeting at this point. Here we got the image. Where is the position of image? Position of the image is in between P and F. Where is the position? In between P and F. There is, we got the image. Then see the size of the image. Is it bigger or smaller than the object? Image is smaller. That means image we got a small one. Here what kind of image we got? We got a small or diminished image. What is the other peculiarities? Is it erect or inverted? See it upside, here also it upside. That means the image is erect. Is the light rays actually meeting? No. So it is virtual. It is a virtual image. What are the things you want to remember about the image of this case? That is image in this case. It is small, erect, in between P and F, and not real. These are the things you want to remember about the image formed by a convex mirror. Now, we want to know about the uses of convex mirror. Convex mirrors being used as most importantly it is used as a rear view mirror by the drivers. They use this mirror to view the object, to view the vehicles which is coming behind them. This is the most important use of convex mirror as a rear view mirror in vehicles. This mirror is used to see the vehicles which are coming behind the vehicle. And here the property of the mirror is that its field of view is very large. Its field of view. Field of view is large because it is curved outwards. Surface is curved outwards, so its field of view is large. Then it always forms but erect image. It always forms what kind of image? It always forms erect image. So when we discuss about or when we remember about the uses of convex mirror, first of all you want to remember it is used as a rear view mirror in vehicles. What are the speciality of it using? Because its field of view is getting large, so large area can be seen by using this mirror, and also it always forms erect image. Then another use of convex mirror is this convex mirror is used, large convex mirror is used in steep curve or big curve to see the vehicles which are coming on the other side of the curve as a safety measure. They are also using convex mirror. Now another one question is that that means to get a full image of any object, even it is small or big, at a distance, what kind of mirror we can use? To get a full image of any object, we can use what is a convex mirror. Only convex mirror can give full image of a large object. If it is near or distant, it will give what is a full image of an object. With these all things, we can conclude this class. Okay.